Hi. All right. Thank you for watching. This is Olivos Motion Picture Productions Chemistry Lessons, Volume 1. So over here what we're seeing is a problem that I've been asked, how do you do this type of problem? The problem that involves NBS with the radicals. So I'm going to explain it, show you the mechanisms to it. So look, this is NBS, this is peroxide, this is HV, light. Okay, this is the compound is making these products, and the question would be, what are the ways to make it? Okay, just let me make that line there. So before I begin, I want to put a little side note. Whenever I'm dealing with these radical problems, I like to have a side note so that I can know that I'm on track, okay, if I may. So listen, usually when you're dealing with radicals, you're dealing with three major steps: initiation, propagation, and termination. Okay, now this is a side note regarding only radicals. Okay, so what you have here in initiation, you would have none making all radicals, and then you would have in propagation, you would have some radicals, and there would still also be some more radicals on the other side of the arrow. And in termination, you would have all the radicals, and then in the other side of the arrow, you would have none. Okay. Now this is a way, like I said, that I can make sure that I'm doing everything right. You could also double check that it matches. Along the way, we're gonna see that it makes sense and it does go along with the process. So let's begin with NBS. What is NBS? Okay, so NBS, it looks like this. This is the guide for NBS. Alright, and your bromine. You see? That's NBS with the alkene. Don't forget your alkene. Some people may forget it. So it reacts with light here, okay? Let it react with light. What you're doing, if you let it react with light, you're initiation step. You're initiating the process now. So let's just start it. So what happens here, okay, let me make this clearer here. You see, in this bond, you have a radical here and another radical there. You have two electrons there, right? So what's gonna happen here is that this electron will go here. Notice how I use a fish hook, okay? Let me make this bigger. I use a fish hook like this, okay? I did not use a double ended arrow or an actual arrow. You know, double-ended arrow would be for resonance, or just one arrow would be for moving of electrons, two electrons, a pair of electrons, and for just half of an arrow, which is also known as a fish hook, is a moving of an electron, this one, also known as a radical. Okay, so moving on, so this other radical, this other electron will go right there on the nitrogen. Okay, so what does that make? Okay, I'm sorry about this dark spot right here on the board, so it's kind of hard to see. Let me just try to read it to you. You have the same thing. You have your NBS, but instead of your bond right there, you're gonna have that little electron, that radical. You would also have your bromine, but it was not bonded together anymore. Now you have it separated. You still have your radical right there. Okay, so this is the first step. Okay, your initiation step. Now, what some people may ask, what about these double bonded bromines? Like, where did it come from? Okay, so in the little side note, what I like to do, side note again, I like to say that bromine radical and another bromine. You see, this is technically a termination step, but it's in the initiation step. This right here. You see, this belongs in the beginning. You want to have it displayed so you don't lose any points when you are developing this process, when you're making this process. You're showing the way because it's gonna make more sense later on where the bromines come from. So this is technically in termination. All right. You see, these are your radicals. I'll try them black for now because that's not really the most important radicals that we have to think about. So let's move forward. Okay. Another thing that you have going on in the initiation step is your peroxide breaking apart. Okay. The peroxides, what they would also do is they would also give you two ORs, okay, and initiation. So now moving on to your next step, your propagation step. Propagation step. Propagation step 1, let's call it 1. Propagation step 1. So let's just look back over here, following this step here. Initiation, you have no radicals making all the radicals. So you have no radicals here because this is just a bond right now. Really, this is just a bond. But then you make the radicals, so it matches for initiation. Now for propagation, let's use this compound, the original compound, put it over here. Okay, the whole point of this is to show how this becomes this. In your initiation, when we showed all the radicals, how the radicals will form. Okay, so you have your alkene here, and you have your methyl. Okay, when you don't see anything like an H attached to a bond there, it's assumed that it's a methyl. What's a methyl? It's H, H, H. Okay, a carbon with 3 H's. All right. So what you do here, now you have, let it react with your bromine. Putting that bromine into play because that's what you really want. Because you see, you have your bromine in your final compound. You want to make your bromine react. So how would it react? Okay, what bromine could do now, you could take your bromine. You see what I made there? I just added a hydrogen, but it technically was already there. We just assumed that it was there. But when there's nothing there, as you know, there's a carbon there that's attached to 4 things because there's no negative charge or positive charge. So it's a carbon there that's 1, 2, 3, and the other part would be the hydrogen bond. Okay. So now what you do, you take that radical and you take this other electron and you put it together. Okay. Again, when you see a bond, you have 2 electrons floating together. Okay. So and then this other electron, hopefully you can see, it goes right to the carbon, to this carbon. Okay. So what this will make is, you could imagine, let me go this side so you can still see what's going on over there. This is going to make your radicals stay right there. Let me put this in a different color so you can mix more of a significant effect there. Your radical goes there, and now you have HBr. Okay, so you have your HBr and your radical there. Okay, and this is again what we could also do here if you wanted to. Look, you see this from this step. This is another important step here. You could show resonance, right? When you have a radical, we can make it go around. Okay, you can move it around. All right. So, but let's just say, for instance, what does this look like? Is this getting close to any of the compounds? Yeah, it's looking like compound B up there. Okay, you're just going to add the bromine. in a step, coming up. But right now, you're showing the resonance. From that radical, right, you can move this radical over to this bond, right? And then this, one of the electrons that's right there is gonna be able to be moved up there, and this one could go down there. Why? So that you can make this compound A. So now you could have that there and that there. So now look, that looks like your compound A, because you could just add a bromine to that radical, alright? So now what we could do is just continue on. Oops, I don't want to say that the radical is not around, because your radical is floating there, okay? But I just want to separate the steps, alright? So going to your propagation step 2. Alright, so what you have is in propagation step 2, what's happening is the formation of those compounds now. Those formation of those desired compounds. So let's go with your compound B, which was like the first compound that we were able to make, at least the similar compound. Compound B had the alkene here at the bottom, and your methyl group up there with your radical right up in the top there. So what happens there is that you could add another radical. Okay, so now you finally asking, oh, where are these radicals coming from? They're all over the place. Okay, like I said, you still have a bunch of radical bromines hanging around. When you broke it apart, you make a bunch of radical bromine. So now this electron could go over here and go there, so that you can make your real compound, your desired compound. I don't want to say real, because all these compounds are real. They're all happening like spontaneously, but we just classify them in different steps. Okay. So what you have here is now your bromine. Let me tell you something really important about this step here, and your alkene down here. Okay. So now you see this step right here. Now that you just added your bromine, you gotta have your stereochemistry. Okay. Don't forget your stereochemistry. And it's racemic, so what you can just do is squiggly line. Okay. Okay, so that's one of the steps, alright? So now your other compound, you see this is compound B. Okay, so now your other compound, you have your, where you use your resonance movements, and you have that radical down here, plus your bromine and your other radical. You take that bromine radical, you make that other radical go there, and it's going to combine to give you that other compound that you've been trying to get. Now you finally have it, and you have your alkene, and you have you still have your methyl, but remember, always stereochemistry. This is going to be racemic, and don't forget you also have a racemic hydrogen right there. Okay, now that's your compound A. Alright, so we're getting really through, but just want to make sure that you understand what's going on. You see, make sure you're following your signal of propagation. You have some radicals before the arrow and some radicals after the arrow, and you still have some radicals this is, you're making it in your propagation step here, but it's still considered your you can see that it looks like a termination step, but it's still considered like propagation. But going on to your termination, step. Some could argue this is a termination step, but let's just say this is propagation step. All right. So going over here, in termination step, what just happens is just that all the radicals you ever formed, you ever made, now finally gets combined, and then you would just have your BR. So you have all these different combination of radicals. You have more ORs and your peroxide forming. Okay, and you still have your NBS. All your NBS peroxides forming to get those bonds back together. There's a whole bunch of ways that you could get your radicals to disappear. There's still more. You could use you could have used like a bromine and OR. It's a combination. It's just different combinations. Right? And so on. But that's basically it. The final question is, what is the major, what is the minor? And to just answer that, the major product would be the alkene that has a more substituted site. So if you look at this one, this alkene is more of a Hoffman product. It's just like one here and one here. While this alkene, you have two things attached to it up there and one attached to it down here. So this is the major product. Also, this is a lilac right here. Lilac is when the alkene is one carbon away to the bromine. Okay, so that's basically it, guys. I hope you understand now this better. You understand this better. If you have any questions, let us know. We try to respond as soon as possible. And thank you for watching. This is Olivos Motion Picture Productions, Chemistry Lessons, Volume 1. Thank you.